Hello, this is AMET 104 lecture recording week 8.2. So last class we looked at different examples that you may encounter in chapter 15.2. That was learning about how to calculate mean, or in other words, average. We also did median, different percentiles. We also did quartiles, and lastly we did the box plot. It was a lot of information, but I would assume that we have done enough. We have seen enough examples that you are comfortable enough to find each of the numbers that we went over. Okay, so today we're going to start on chapter 15.3, and that is ranges and standard deviation. So let's first talk about the range definition. Range. So the range denoted R of a data set is given by the difference between the highest and the lowest value of the data. So simply put, this means that the range is the difference between the maximum and the minimum. And that would make sense because if you want to find the range, as the name suggests, it means that where the data lies. So you would have to, this basically means where the data starts and where the data ends. And the range basically implies the distance between the 2 points. So to find the distance, you subtract. So you take the maximum value first and take away the minimum value to find the range. So range, I would assume it's very simple enough for most of you, but there is another thing. So the range usually in itself is not enough information. If we were to record all the SAT scores of the entire nation, we can find the range, but usually knowing the lowest point and highest point and the difference between the two doesn't really say much, even though it is important. So to eliminate the possible distortion caused by outliers, a common practice when measuring the spread of the data is to use the interquartile range. In other words, IQR. So what is the interquartile range? So this is a definition. IQR is the difference between the third quartile and the first quartile. As the name suggests. So here it would mean that IQR is simply Q3 minus Q1. So what does this number represent? So you'll find, so you have the third quartile and you have the first quartile. And if you take the difference between the two, in other words, if you find range between the two quartiles, it'll actually tell you how spread out the middle 50% of the data value is. So the IQR tells us how spread out the middle 50% of the data value. R. So in a lot of the applications in real world, the IQR is actually really useful, and oftentimes it is used to measure the spread of data. So before we go over, why is the middle 50%? So if you have data, so let's say these are the data points. This is a weird representation of data points, but let's say each point here is a data point. And the first quartile would, so let's say this is the first quartile. Since this is a 25th percentile, this means that there are 25% of the entire data lying before the first quartile. And if you look at the third quartile, Q3, you know that this is the 75th percentile, meaning that the left-hand side of this Q3 is 75%. In other words, the other side, the right-hand side, is 25%. Because the entire data we're looking at, it's a 100% of the data. This means that whatever is in between here is the 50% of the entire data. And I think that's very self-explanatory. So this is important that so range, when we're just talking about the regular range, it's the entire range from the minimum So this is the minimum and the maximum. And it interprets the spread of the 100% of data. Whereas the interquartile range, IQR, represents the spread of the middle 50% of the data. So both together is a very useful tool to how to interpret the spread of the data. So let's actually put that into an example. So last class when we were doing example, one of the last examples were about the age distribution. It didn't really have any context. It just had a distribution of age. And so this is an example from last class. And here I'm going to skip all this small little details, but we have found that the minimum was 21 years old and the first quartile was 23, the median was 26, third quartile was 28, and lastly, the maximum was 31. And here we drew the box plot. Let's actually do that again. So we had 21, 22, 23, 24, 25, 6, 27, 28, 29, 30, 31, 32, let's say 33, just so I can fill out the rest of the number line. And the box plot was as such. So we draw the box on the left-hand side of the edge is the first quartile, and the right-hand side goes up to the third quartile. And we have the whiskers that extends to the minimum and the maximum. And we have the median. So we can see that this is the minimum, this is the first quartile, median, third quartile, and lastly, maximum. So this is what we did last time. So from here, let's find the range and interquartile range of this example. Excuse me. So the range R, we know that it's defined as the difference between maximum and the minimum. And since the maximum is 31 and minimum is 21, we can take the difference and conclude that the range is 10. So this means that the spread of the data is within the 10 years of age. That's all it's saying. And when we're talking about the interquartile range, which is the third quartile minus first quartile, and in this case it's 28 minus 23, so that's 5. In other words, the middle 50% of the data set lies in between this 5 years of age. That's all it's saying. And as you can see from the box plot, the box in the box plot basically represents the interquartile range, and the whiskers from the lower whisker to the higher whisker, it basically represents the spread of the range, entire data. I'm sure that's enough information, but let's do one more example, one very quick little example, but in context. So let's say distribution of statistics data set. It's not the statistics, so SAT data. So let's say 5-number summary of SAT score is given as such. So 5-number summary implies these 5 numbers: minimum, first quartile, median, third quartile, and the maximum. And we're given that the minimum is 200, which means this specific student did not, this means that there is one student, at least one student, who did not get anything right. And let's say the first quartile is 430. Median is 510. Third quartile is 590. And lastly, the maximum is given as 800. So somebody got the full, like every little problem correct. So I'm not going to draw another box plot. We've done enough box plot examples, but just to save you some time, the range is maximum minus minimum. So it'll be 800 minus 200. So that is 600. This means that 100% of the data, so every possible scores lies within this 600 point spread. And the IQR, since it's the third quartile minus the first quartile, you can take it 590 minus 430, and that is 160. And this tells you that the middle 50% lies within the 160 point difference. So I think that was enough information about the interquartile range and the range. So let's actually go over and do something else. So the second part of this chapter is about the standard deviation. So the standard deviation. And the standard deviation part is where it's the most time consuming. The concept itself, I don't think it's hard to understand, but to find the standard deviation, it takes a little more time. It takes time to find a standard deviation, especially if the data is bigger. So it's important that you understand what the standard deviation is and practice several times so we can shake some time off whatever you're doing in this course. So for example, if you're doing an exam, if you can find the standard deviation really quickly, that'll shave off a lot of time from your exam. So the most important and the most commonly used measure of spread. for a data set. So this measures, so it is a measure of how far away a data is away from the mean. So I think going over how to find the standard deviation is the first thing to do. So simply said, standard deviation is simply the measuring tool. It's simply a measure of how far a specific point, if you want to find how far away a specific point is from the mean, this is the tool to use. So someone might argue that why wouldn't you just take the difference between the mean and a specific point? That's a very good point. However, we're talking about the standard deviation. That talks about the deviation, but by making a standard deviation, standardize the measure of data. So usually when we're just talking about the deviation, it tells you the raw difference between the mean and the specific point and that distance. So for example, if we were talking about the age, the difference between the mean, whatever the mean was here, with a specific point is going to be a few years difference. And that is that. But if you were to calculate the SAT score and find the deviation between the mean and a specific point, it's going to be at least 100 points away. And now that makes it not uniform. So the standard deviation is basically standardizing all the distance and making sure that it's a tool to measure distance in a very standardized way, as the name suggests. So these are the steps to find standard deviation. So the first step. So let A denote the mean of the data set. And the second step is for each number, I'm going to say x is just a number in the data. Compute its deviation from the mean. And that means find x minus a. So for each data point, you have to find this number. So if you have 10 different points in the data set, you will have 10 of these numbers separately. The third step, square each of these numbers. And this is also known as the square deviation. And simply put, it's squaring each one of the x's. The next step is to find the average of the square deviation. And this is called the variance. And lastly, the standard deviation excuse me. And I'm going to denote it as sigma. Is the square root of the variance. So simply put, the formula is not actually given in the textbook, but they only tell you how to find it, because the formula in itself makes it look a little more complicated, but I'm just going to give it to you. So the standard deviation, this is not 6, this is a sigma, and is the sum. This implies the summation of x minus the average. You square each of them and you divide it by the size of the data. And this is very complicated, but I personally do prefer this notation. Hopefully it'll make more sense after a few examples. Let's do one example about the standard deviation. Let's say a student received the following scores in their homework assignments. Let's say let's actually write out everything. Over the course of the semester, Angela turned in all over homework assignments. Her grade in the 10 assignments were as such. And these are just sorted data from the lowest to highest. 85, 86, 87, 88, 89, 91, 92, 93, 94, and 95. So suppose that was the raw scores that she received in this 10 assignments. So let's find the standard deviation. So a standard deviation, the first step is to find the average. So average A, we can see simply add everything and divide by the number of assignments, which is 10. So let's do that. 85 plus 86 plus 87 plus 88 plus 89, 91, 92, 93, 94, and lastly 95. And by dividing everything by 10, because there are 10 assignments, you would receive 19. So this means that her average score in this class with 10 assignments is 90 out of whatever it is. So that was the first step done. So we denoted the average as A, and that is 19. So before we go on to the next step, let's actually make a table. That'll make it a lot easier. Let's make a table like this. And the first column is X, meaning that it's an H point. So that's, you get 85, 86, 87, 88, 89, 91, 92, 93, 94, and lastly 95. And since the next step here, you look at step 2, is to find the deviation from the mean. So X minus A for each of these values. So let's say for the second column, we do X minus A. Let's find that. In this case, since we know the average is 90, let's actually write 90. So the first row, the second column, will be 85 minus 90. So that is -5. For the second row, it will be 86 minus 90, so it's -4. 87 minus 90 is -3, -2, -1. 91 minus 90 is 1. 92 minus 90 is 2, 3, 4, 5. I hope that made sense. I thought that was very straightforward. Now for the next column, let's find the square deviation. So that's the third point, is a square each of these numbers. And you are simply taking each of these numbers from the second column and squaring it. So the square deviation is X minus 90, and you square it, meaning -5 squared is 25. -4 squared is 16. -3 squared is 9. -2 squared is 4. 1, 1, 4, 9, 16, and 25. So now we have found the square deviation for each point in the data set. And it's simply found by taking each number from the second column and just squaring it. The next step, the fourth step here, is to find the average of the square deviation, and that is called the variance. So to find the variance, you're simply taking all these numbers and find the average of these. So we know that there are 10. So to find the variance, you're simply taking 25 plus 16 plus 9 plus 4 plus 1 plus 1 plus 4 plus 9 plus 16 plus 25, and you're dividing it by 10. And this is the variance. I'm just going to call it a V. So by putting them into calculator, you should be able to find that this comes out to be 11. And then we're almost done. The last step is the standard deviation. So the standard deviation sigma is the square root of the variance. So now that we know the variance is 11, then the standard deviation is found by square rooting the variance, which in this case was square root of 11. And unless otherwise the problem says so, it's okay to leave it like that. Or if you put that into calculator and round to the first decimal, it'll be 3.3 points. So 3.3 points here is the standard deviation of Angela's assignments in this specific class. So I understand this is a very confusing concept. It is however, very useful. So for a data set that are based on same underlying scale, the comparison of the standard deviation is very useful, and it's very useful, and it tells you a lot of things. So just before I let you go, I'm going to make one remark. The standard deviation tells us how much the data are scattered. In other words, if standard deviation is small, the data points are bunched together. And if standard deviation is large, this means that the data more scattered. So that's it for the class. So next class, I'm going to go over different examples. I'm going to dedicate the whole class to go over the examples with the range, interquartile range, and standard deviation. Probably spend more time doing the standard deviation, and that's it. So thank you for joining the class, and I hope you have a great rest of the day.